We're ready.
Here he goes. Internal Services Department, ISD, we provide essentially support services for all the departments of LA County. We provide IT services, including managing all the data centers facilities with over 1,100 IT professionals. Our objective is to service all citizens of Los Angeles County with the highest quality of service and reliable access to the application and data. Our mission is to be trusted partner and provider of choice. ISD supports 39 county departments who actually provide services to over 11 million users. We support over 3,500 virtual machines and over 500 websites. Some of our critical websites, child support services, they work on over 350,000 child support cases every day. Mental health, it's one of the largest county mental health, Department of Mental Health in the country. They have over 80 programs and they work with over 700 providers. Cannabis management, very popular site in 2018. I would recommend you guys to visit this site if you live in California. It's very, very informative. Homeless, county's movement to combat this crisis is very important to Los Angeles County. And Los Angeles, LAcounty.gov, which you have access to all the services of Los Angeles County, places to see, things to do, jobs, and much more. We started hosting our websites on mainframe back in 2008. With that, we had some challenges, such as to apply any updates, we had to stop all the services and applications on the mainframe running on WebSphere. To minimize any risk, we had to do code deployments only once a week. Onboarding process from where we get the request from the customer to when we can deliver the service was typically taking about a month. In 2015, due to high demands for open source, we started hosting our websites with WordPress on LAMP-Stack. Well, some challenges with LAMP-Stack, in order to comply with our security, we had to provision multiple VMs, hosting the web services in DMZ and the database on intranet, and opening ports, configuration, customizing it, of course, keeping it up to date, all the VMs with patches and upgrades. And if our customers needed any more environments such as dev or test, that would be additional cost to customer. This service delivery was taking us about a week or two to be able to actually give access to customers. In 2016, I reached out to Red Hat, and we wanted a solution where we can have some automation. We can have a faster provisioning and deployment. It's something it's easy to use, very simple. It's quickly recoverable. We can use maybe standard images and offer that as a self-service. So with the help of Red Hat, we were able to design and implement our first OpenShift cluster version 3 in our environment, in our data center. And the first, our intranet portal intranet for over the first intranet website that we came up with, when it got launched like successfully, was in 2017. The site is accessible by over 100,000 employees with actually over 50,000 daily login transactions. With OpenShift, we have consistent environment, the same version for OS and middleware. The on-demand infrastructure, it allows us to offer self-service to our customers. With automation of build and deploy, it makes this process much faster and easier. Delivery pipeline integrated with security, it gives us the ability to secure and automate a secure end-to-end solution for our customers with a unified operational model where it doesn't matter what kind of application we manage and deploy on OpenShift. We have one OpenShift cluster that manages multiple environments. Since majority of workload and applications that are running on OpenShift, it's with WordPress, I'm going to show you that how we work with WordPress. We pulled the latest version of WP Core from upstream. We merged that with our master branch in our Git repository. And then we use source to image, strategy build to deploy that into our dev environment. We are working on a CI/CD pipeline in our Jenkins to be able to promote the code and content into test environment and then to QA. Once we have the site on QA, we run security scan and load testing if needed by customer. And then once it's validated by customer and approved by our security, we promote that into our production environment. All of our web applications in productions is protected by WAF. When we started OpenShift, we started with NFS resource node, and because that's the only thing that was available to us at the time. With that, we have to manually create and delete NFS exports for each environment individually for dev, test, QA, and prod. We manually create corresponding persistent volume and the fact that resource node is a single point of failure. If we lose that node, we lose all the sites. With GlusterFS, the persistent volumes are created automatically. We can actually define it as a storage class in our template, and it's highly available. We're working with Jenkins and GlusterFS to be able to provide one-click project provisioning to our customers and give them ability to do more updates in their environment, as well as instant rollback by blue-green deployment. I'm going to take you an example of deploying a website by customer. Customer goes to our service catalog, eWeb services. They input their information such as their name, account number, email address, as well as the environment they want to provision. In this screen, they can either provision one environment or they can do multiple environments, including dev, test, QA, and prod. Once they submit their information, the data gets passed to Jenkins through API, and a build job gets created. It goes through creation of the application. The GlusterFS, the storage is allocated automatically because we're using Gluster FS in our template as a storage class. The pods getting spin up, MySQL and WordPress. 1 for MySQL and 2 for WordPress for redundancy. So this is equivalent to 3 VMs that we had to do when we were on LAMP-Stack, which took us about a week or 2. And as you can see, this is only taking us a few minutes. The job is built. The customer gets notified with a link to their WordPress admin page with the user credentials. Once they log in with the username password that they provided, they get access to the dashboard of WordPress. And as you can see, this only took about less than 3 minutes. From here, they can deploy their website, a couple of minutes. Just as a recap, on mainframe, it took us about 30 days, typically. On LAMP-Stack, about a week or 2. And now with OpenShift, we're able to actually deploy a website less than 15 minutes. Wow. Thank you very much.
Thank you. Wow. Wow.
That's for Annette.
Yeah. Thank you, Roya. So what we're going to do next is going to look under the covers at the storage that Roya mentioned. And when I asked how many people have actually tried the container native storage, there were a few hands, but not too many. So some of these concepts for people who have might be a little bit elementary, but I think we should go through it. So we know now, I guess, that OpenShift and all PASs need 2 types of storage, right? Stateless apps didn't do what they were supposed to do. And as soon as people started putting apps on platforms, they wanted persistent storage. So OpenShift is no different. And the persistent storage can be of different varietals. Today I'm going to talk about how we can do it with Gluster. The OpenShift infrastructure that you see there, the container native storage or the Gluster is now baked into OpenShift via the OpenShift Ansible to actually automatically back those 3 infrastructure services by Gluster. So you can modify your inventory file, and when you get done, you have the cluster built and you have those backed. I'm not going to go into a lot of detail about that, but I just wanted you to know that as of today, with OpenShift 3.9, completely automated. So how does it work with OpenShift and persistent storage? And this is true really for any dynamic storage claims. Gluster FS is a dynamic provisioner for Kubernetes. It was one of the first ones, and that is what we're using in this case. So a developer, or in the case of what Roya said, they're going to, in the case of Roya's team, they're actually doing this request. But if it was another environment, it could be in a developer template if they had access to the OpenShift. So there's a request for storage, and there's usually a request for the mode, like read-write only, read-write mini. That goes in the request, that will go to a storage class. And in the storage class is where the Gluster FS provisioners is, as well as the information about how to get to the API. The API that we're using is called the Heketi. And Heketi is the one that will actually go down and provision the storage. And then it will deliver the storage back to OpenShift, bind it to the persistent volume claim, and then it can be mounted on a workload. So Roya discussed 2 workloads that they're hosting primarily, MySQL and WordPress. Both of those have a need for persistent storage. So in the case, those workloads would be using the persistent volume that came from Gluster. So container native storage is a replica 3 solution. So the Gluster volume that's created, or the volume that's created, is a replica 3. What that means is, and I brought up the keynote if you went today, you saw there were 3 sites. I said it was one big volume, and every time that the active side wrote something, it was replicated to the other two sides. That's exactly how container native storage works. So I don't know if I have a, do I have a thing here? Yeah. So we see here, this is just an example of two storage types, two clusters. We have one that maybe is fast storage, like let's say it was AWS GP2, and maybe we have an AWS IO1. So fast and faster. The clusters, or the containers that are the cluster pods, they can reside on any of the OpenShift nodes of the type infra, app. Basically, they don't usually sit on masters, but they can be on any of the OpenShift nodes. At a minimum, to do the storage, you need to have 3 cluster pods, but those cluster pods do not need to be co-located with any other workloads. They could be or they could not, but they serve storage for all the workloads, whether or not there's a cluster pod on that OpenShift node or not. So that's just the point I'm making here. It's not, the storage is essentially available to all the workloads, and you can put workloads, you can put a cluster pod and other workloads on the same OpenShift node, or you cannot. You could have just a cluster pod on its own OpenShift node. The way it works, when I went through the diagram there, OpenShift makes a call via the storage class into the Heketi API, and then the replica 3s are set up. So it's a little bit confusing, but you do need to have a minimum of 3 OpenShift nodes because it's a replica 3. But you could have more OpenShift nodes in your cluster. But each volume, it's sort of like this. Each volume will touch 3 of the storage points, or 3 of the nodes. But you do need a minimum of 3. But you could have 6, you could have 4. For one cluster, our recommendation is 4. The reasoning for that is to support a cluster volume, you need 3 replicas, so you need 3 nodes. If one of the nodes goes down, you still have 3 up, therefore you can continue to create volumes. Cluster is based on a quorum, so for volume survivability, you only need 2 of the 3 to be up. So if one of the nodes goes down, and you have 4 nodes in your cluster, you'll still be able to create, you'll still be able to do everything. And even if 2 of the 4 went down, all your volumes would behave completely fine. As soon as the other 2 come back up, they would be what we call healed, which is all of the data that had come in during that time written to the volumes would be copied over to the ones that had been down. So that's sort of a quick thing about how Gluster works in terms of being highly available. And I think Roya had it on one of her slides, but one of the reasons when I first met her team that they were very interested in this is right now, or with their NFS solution, they had a single point of failure. So if that NFS server or servers were unavailable, they did not have any storage. So over here is an example of a storage class. So we have the provisioner, Gluster FS right there. We have the name. This is something that's user initiated or user decided. You make up whatever name you want. I like to have names that are somewhat explanatory of what the storage, what is the storage, like if it is fast or slow or something that helps. And then we have the route to the Heketi service. Heketi actually, when you do the deployment via OpenShift Ansible, you actually get a Heketi pod. So Heketi runs in a pod, and this is the route to get to it. And then you have some additional authentication. This is a user for the Heketi service, and this is an OpenShift resource, which is the Heketi secret. So the API is not open. You have to authenticate to use this API and create PVs. The other thing I want to point out here, there are 2 modes of how this can be used. I've only spoken about the one where Gluster is in pods, but Gluster can also be outside of the OpenShift cluster. So just a little bit about Gluster. If, excuse me, if you were to build this out there and you logged into one of the Gluster pods, you would use all of your Gluster services, just like if you were on any Gluster node. So, and Gluster is a POSIX-compliant distributed file system. Yeah, like I said, it's been around as a Red Hat product for, almost 10 years now? So there's a lot of experience, a lot of testing, a lot of information about Gluster. Really the change here is just having the Heketi service and the provisioner for OpenShift to be able to use it via the Kubernetes. It's a Kubernetes dynamic provisioner, a volume plugin. So what I want to do now is, hopefully this will work. It's not working again. I don't know what's, sorry, we're having some problems with our embedded videos. Oh, no, wait, it is, you got it, okay. So what I want to do now is, this will take about 8 or 9 minutes, and it's already started, so I'll try to talk fast. So I'm going to just do an example here of what it would take to provision persistent storage using NFS and what it would take to do it versus CNS. So I'm just making up a scenario here where we have approximately, we're onboarding and we're offboarding. So we have like 75 changes or 75 needs that we need to do with storage. I'm going to do it as an onboarding of an actual MySQL instance, and I'm going to then compare the time if I had to use NFS versus CNS. So we're starting on the NFS server because we need to create the logical volume, and we need to export it. We need to go ahead and do some permissions on it, which will be next up here. Sorry for the colors if you can't see them. That is blacked out because that's permissions info there. And then we need to export it. So this is how you would actually make it available to OpenShift. This has nothing to do with OpenShift right now. This is just creating something that OpenShift can now use via NFS. So the next step after this, once we've got the work done on the NFS server, we need to now go into OpenShift. And if you've used OpenShift CLI, that's what I'm going to show. But we now need to do some additional provisioning on the OpenShift side. So we've exported on NFS. Now we need to create what's called a persistent volume object that's going to point to that NFS server, and it's going to point to that volume that we exported. And you can see here that we have the actual server, and this is whether it's a group of servers or servers, that is a single point of failure right there, right? And there's the volume that I just created. So we're gonna create that via the YAML, and you can see that it's here. It's been created. So the next thing I want to do is now I want to use this in a project. So I create a new project. And I'll go into the web UI, just see that I have my project, see what's in it. Since we haven't done much, there shouldn't be much in it yet. So there's nothing in it right now. It's just a new project. So if you've used OpenShift, you're probably familiar with templates. And Roya said that they're using these in their Jenkins. So within a template, if it's you have the ability to do a persistent volume claim. And you can specify there the size of the claim. And in our case, because it's NFS, we're not using any kind of storage class or anything. So via that template, we're going to create all of the resources needed for this MySQL instance. We can go back to the UI. We'll see the pod spinning up. If we go to the storage, we can see that it's using that persistent volume that we created that points back to NFS. Our pod is now running. we can see that it is 10 gigabytes as we specified. And this all happens, again, via the template. We didn't have to go in and mount it. But if we do look at the mount point, we can see that it specifies the server, and it specifies that logical volume that we created on NFS. So that's what it would take. And I mean, obviously, you could see if you had to do this a lot, you would do some scripting, but that's what's happening behind the scenes. So now let's contrast that same operation with container native storage. So with container, exact same workload, same everything. With container native storage, one-time effort, create the cluster, create a storage class. This storage class is just like the one I showed on the slide. It has the name. It has the REST API information for Hiketi. And that is what is going to go ahead and get it to the storage pool that was created, the Gluster pool. So now we're ready to create a new project. So create a new project. Take a look at it in the web UI. I used a different namespace, obviously, because it's a different project. So it's MySQL CNS. We need now to add to our project. We use exactly the same template. But there's one, I guess, critical difference, which is why they're now able to do this one-click provisioning, is we are now able to specify that storage class here. And what we claim, that 10 gigabytes that we claim, will come out of the larger storage pool. So for example, your storage class or your storage cluster could be 1 terabyte. You're taking 10 gigabytes out of that 1 terabyte. So now we deploy it just like we did before. Go back, see the pods coming up. Look at the storage. It says using storage class CNS cluster FS. Really important point here, that PVC was automatically created. I didn't have to do any JSON. I didn't have to create it. As soon as I did the template and created the PVC via the template, that PV was created, and it's a Gluster volume. So now we'll go ahead and look at what's happening with the workload. Looks like it's almost done. So there's the PVC that was created via the template. And this is the persistent volume. Another important point here, the reclaim policy is delete. You can change that, but by default it is delete. And what that means is that in Roya's case, when they don't want that project anymore, they go delete project, all the storage all the way down is freed up. And we can see now the volume, that volume _15, that is the exact name on Gluster. In the newer releases, we have some nicer naming capabilities in the latest CNS release, but this was a prior release. So now this 10 gigabytes is here, mounted for the workload. So getting back to our comparison, just real quick, making some assumptions about how long it takes to do NFS onboarding versus CNS. We're looking at about a 4 times reduction or a 4x reduction. And again, these are just assumptions, but I think an important point is also, to do the NFS work, you have to have administrative access or you have to have some kind of admin privileges, and there could be errors in the way that you provision NFS. Just want to mention one more thing before I finish, is also with NFS, I'm not showing the cleanup on any of these, like I said with CNS, because it's delete. As soon as you delete the project, all the storage is deleted. With NFS, if you delete the project, you still have the PV, the OpenShift PV, persistent volume sitting there. If you want to clean it up, you have to clean that up, and you have to go back to NFS and remove that logical volume. So hopefully I have convinced you that CNS is like the best thing ever. And
ahead of
Okay,
time.
well, thank you very much for coming, and
you.
hopefully it was helpful.